Welcome to Mech-Knowledge. In this video, we are going to analyze a 2D structure with the help of the ANSYS. First, we will open the ANSYS Workbench. This is a 2023 release 1 model. With the help of this, we are going to do a thermal analysis for the 2D plate with having a dimensions of 100 cross 200 mm. It is opened. After that, you just double click on the fluid flow fluent because we are going to analyze a full setup. So double click on the fluid flow fluent. In that you have geometry, mesh, and everything will be there. In fluid flow fluent, just rename it. Give flat plate thermal analysis because we are going to do analysis for flat plate in 2D structure. So after giving this, verify it, and then you have a number of domains in the fluid flow fluent itself. You have geometry. With the help of geometry, you can do it, a meshing, and then setup, and then solution, and then finally we will get a results. First step is to open the geometry to do a 2D structure. First we will open the geometry, right click on it, give design modeler. After that you can able to open the geometry. You just click on the XY plane. After clicking XY plane, make it normal, and then make the unit as millimeter. Initially it will be in meter, just change it to millimeter. After that, go for sketching. Click on rectangle. Put a rectangle which having a dimensions of 100 mm in the X and 200 mm in the Y direction. I gave 100 mm, and then just click on the Y direction line and make it the dimension as 200 mm because we are going to analyze for this flat plate. After giving the dimensions, we have to make a surface fill. Go to concept, give surface from sketches. After that, click on the lines, 4 lines in the rectangle. Click on the 4 lines by using control. Click the 4 lines by using control, and then give apply. Add material, you just give add frozen, and then generate. After generating, you can get a surface filled figure in the 2D structure. This will be further used for meshing process. Go to mesh and then give update. After giving update, you click on edit for meshing. On meshing, you will get a mesh tab. In that you can able to do a meshing process. It is a 2D figure where you can do a meshing. Just click on mesh, right this and insert, give sizing because we are going to do divisions over here, and then click on the edge symbol, click on the Y direction line, and then control, click on the another side, and then give apply. Instead of type, you just instead of element size, you just give the number of divisions. In number of divisions, you just split into 100 because this is a random value we are giving. Then generate mesh. After giving generate mesh, we have to do again on the X direction as well. The X direction, go to side, again follow the same step, and then click on the 2 X parallel lines, give apply, and in the element size, go to change it to divisions and give the number of divisions over here as 50. This is the main important thing. In Y we have given 100, and then X we have to give a 50, and then give generate mesh, and then click on mesh. You can able to see. So in this diagram you can able to see it is not uniform, so we have to do a phase meshing so that the meshing structure will be in uniform. So go to phase meshing in the insert option. You can able to see here. After that, click on the surface, give apply, and then generate mesh. After generate mesh, if you click the mesh, you can able to see the mesh is in uniform condition. I'm zooming over here, you can able to see. So this is a step we have to do in meshing, and then we will update the mesh process. Next we have to go to the setup. Just click edit, and then give double precision for better accuracy. Here 1 is enough, but if you give 10, it will be more fast. And then the fluent will be opening over here. If you are giving 10 processor, it will be very fast, and you will get output within seconds depending upon the structure what you are analyzing. So here you can able to see the structure in green color. If you are able to see here, then we have done without any mistake. Here there are number of tabs. Scale, check. If you give check, you can able to see over here in the down. Report quality, display. In the display you can able to see. Here we are not given the top, bottom, left and right surface. We have to give it. By mistake I have not given. Go to mesh again. We have to give the top, bottom and right and left again. So just click on the edge. By clicking on the edge, create named selection on the top side, top underscore side. Type it and give OK. After that we have to give on the all four sides. Then right side, create named selection, right side. OK, and then just click on the edge and right click, create named selection, left side and left underscore side, and then click OK. On the bottom side also you have to do the same step. Click on the bottom edge, create named selection, bottom underscore side, click OK. So we have done this named selection. In named selection you can able to see here top, bottom, left and right side. You can able to see here, and then go to setup and give update, because we have to update the named selections what you have done in the meshing just now. Because in setup these kind of top, bottom and left and right should plays a crucial role for giving a boundary conditions. So just click on OK. It is updated over here. So you can able to see over here all the parameters are available here, and then here you don't need to change anything. The default value it will be OK. And then models, go to energy, click on energy equation, because energy equation should be on while you are doing this kind of analysis. So remaining things you don't need to change it, make it as default. Under material you can able to see solid as fluid. So we are analyzing for solid, not for fluid. So double click on the solid. You can able to see aluminum as a default material, density, CP, thermal conductivity, everything is there. So keep it as same itself, then close it. And then we have to go to cell zone condition. Under cell zone conditions we have to give solid instead of fluid, because we are analyzing for solid as I already told. And then give apply and then close, and then go to boundary conditions and double click on the boundary conditions. We have to give the temperature along the boundary. So first we will give the temperature in the bottom wall or bottom side. You can name it anything, bottom side or bottom wall. So give temperature, click on temperature, give temperature as 373 Kelvin. 373 Kelvin is around 100 degrees Celsius. So apply OK. So we are analyzing how the heat is transferring. Click on left side, then give edit, and then give temperature again. You just click 293 Kelvin. After giving a 293 Kelvin, click on apply and close. We have to give 293 in all the sides, right side and the top side as well. Only in the bottom side we have to give 373. Other sides you have to give 293. And top side also edit. Click on temperature, give 293 Kelvin, apply and then close. So you have given the boundary conditions for this flat 2D plate. Then go to methods for under solutions. So you keep it same itself, no need to change it, make it as default. And then go to report definitions. In report definition you don't need to change anything. And then monitors, just double click on the residual. You can able to see the residual values, where the value should be converged. If it is converged during that point, it will be, the calculation will be stopped. And then go to initialization. Under initialization, hybrid initialization is a default method, no need to change it. Give initialize. After giving initialize, give on run calculation. Under run calculation, give number of iterations as 100 as a sample iterations, because it may converge at any nth iteration. So give calculate. Once you calculate, if the calculation is completed, so we will check if under nth iteration is converged. So in the 8th iteration itself, the calculation is converged. So we can able to observe over here, it is the 8th iterations in the x-axis, and the y-axis it is a residual values. It is a values you can able to see in the y-axis as well. And then give contours. If you give save and display in the contours for temperature and static temperature, if you give give temperature, automatically say static temperature, and then compute and close. You can able to see the temperature distribution of the 2D structure. So this is a basic structure. You can able to see over here the red color is a 373 Kelvin and then blue color is a 273 Kelvin. So the temperature is changes due to the heat transfer. So we will move on to the surfaces because we have to make a line. After give a line, just go to x point. X give us 0.05 because the x length is 100 mm. So we have to give the half of the x because the origin is at the center of the rectangle. So according to the center we should write as type as 0.05, and then x1 is a center, like for calculating the center of mass what we are using the same procedure we also follow over here. So half of the 50 mm is at 0.025 meter. So once we given all those things, we have to go for y0 and y1. So in y1 we have to calculate how the y1 has been calculated. So under y1 you need to type 0.1 because the height of the in y direction is 200 mm. So half of the 200 mm is 100 mm. 100 mm if we type in meter, we have to write in 0.1 meter. So there is a basic thing you have to need to write. And in y0 you don't need to change anything, make it as default because it is 0, because at the axis of rotation at the center point there is no y movement, so it will be 0. So no need to change anything. So this is a standard values you need to put over here, then create and then close. Once you create it, go to xy plot, double click on it, and then just give temperature because we are analyzing only for temperature, and then give line 9 we have created just now before previous step, then give save plot. So you can able to see the plot, it's look like in this direction, but it should not look like this. We have to change, we have to modify something. I think we just made an error while we are giving the xy plot. Go to xy plot again, double click on it, and then in plot direction in x just give 0, and then y you just give 1 because the units we have to change according to the desired output, then give save plot. So you can able to see the plot with respect to the static temperature and the position in y and x directions. Then go to xy plot again, and then instead of a position on y axis you just change it to position on x axis to y axis, then give 0 and 1 in x and y, give temperature. So give click on line 9 and save plot. So you can able to get the values. So here you can able to see position on the y axis and the static temperature on the x axis. So in the previous graph it is vice versa. So I will click on the previous graph xy plot 1. So here you can able to see the position in the x axis and the static temperature in the y axis. So this is a basic difference for the case 1, like a same graph only, but we are just changing the figure with respect to the desired condition. And the contours, if you click again, you can able to see the contour. Here the blue color you can able to see 2.93 into e plus 02 is 2.93 into 10 power 2, that is 293 Kelvin. Like that only 3.01 e plus 02 is 301 Kelvin. Just e plus 2 is 10 into 10 power 2. That is the thing. So you can, from this video you can able to understand the basic thermal analysis for the 2D figure. It's a rectangular figure, as you can able to see. It's a rectangle figure with 100 mm cross 200 mm. So I hope this video is useful for you. For more information, subscribe the Mech-Knowledge channel. Thank you.